Okay, so the question says area of a circle is 2464 square meter. What will be its circumference? So clearly we know the area of the circle can be denoted by area is equal to pi r square, which he has said is equal to 2464 meter square. So we can use the value of pi, and then in the same sequence we can find out the radius value. So it's going to be 22 by 7 into r square is going to be 2464, which makes it r square is equal to 2464 into 7 divided by 22. Okay, if you cut this number, r square is ultimately coming out to be 784. So r value will be nothing but under root of 784, and under root of 784 is nothing but 28. So 28 meter is the radius of this particular circle. Now we are supposed to calculate the circumference, so we're going to use the circumference formula. Circumference formula is 2 pi r, which is nothing but 2 into 22 by 7 into the r. R we have just calculated to be 28. So we can solve this easily. This is going to be like that. This is 8 into 22, which is nothing but 176. So that is the circumference value, 176 meter. It is available in option number B, becomes the right answer. The area of a rectangular field is 15 times the sum of its length and breadth. So we need to evaluate this particular condition and make some expression out of it. If the length of the field is 40 meter, what is the breadth of the field? So clearly he says the length he has given as 40 and breadth he wants us to calculate. Area of the rectangular field is 15 times. So area of the rectangular field is given as L into B. He says this area is 15 times sum of its length and breadth, that is L plus B. 15 times L plus B. So it's going to be L, we can write it like L into B is 15 into L plus B. So we have got the value of length. So we'll put the value of length inside this. So it's going to be 40 into B is equal to 15 times 40 plus B. Okay, we need to create an equation out of it. So this on the left hand side is going to be 40B is equal to 15 into 40 is 600 plus 15B. 40B minus 15B is going to be 25B is equal to 600, which gives B value as 600 by 25, which is 24 meters. So we have got the breadth value. Yes, he was asking the question that what is the breadth of the field. So it come out to be 24 meter. It is available in option number A. So it becomes the right answer. Now, if ABCD be a rectangle and PQRS be the midpoints of AB, BC, CD, and DA. So let us make a rectangle first. He's saying that ABCD is a rectangle. Let's create a rectangle. So A, B, C, and D. This is a rectangle. And he says PQRS be the midpoint of AB. So let's make P here, the midpoint of AB. Q, the midpoint of BC. So let's make Q here. Similarly, R here and S here. So PQRS is the midpoints. Then he says the area of quadrilateral PQRS is equal to. So let's make that quadrilateral PQRS. This is that quadrilateral PQRS is there. Okay, so this is how the structure is created. Now he wants to know the area of this particular PQRS over there. So we need to understand that there is a theorem which says if inside a rectangle the midpoints are joining, midpoints are joined, so the structure formed by the joining the midpoints of such particular rhombus or rectangle is the area is half of the original rectangle. So this is what is the theorem, that rectangle formed by, or rather rhombus formed by, a rhombus is always created. A formed by rhombus formed by joining the midpoints, as in our case, by joining the midpoints of a rectangle, or a parallelogram also. Rectangle has area is equal to half of the original rectangle, half of the original rectangle. Okay, half of the original rectangle. So that is what is a theorem. So by this theorem, we should directly tell that the answer is half of area of ABCD, which is available in option number C. Now, the ratio of areas of two isosceles triangles having the same vertical angle, that is angle between equal side, is 1:4. The ratio of their heights is, let's create two isosceles triangle. So this is one, and let's make a smaller one where the vertical angle has to be same. So this particular angle is same in both the isosceles triangle. Also, these two sides are also equal to each other. these are the two isosceles triangle over there. Now we need to know that that they said that the ratio of the areas of such triangle is given as 1:4. Okay, the area is given as 1:4. So let us assign this as area 1, the triangle 1, and this is as area 2. So we clearly know that A1 by A2 is going to be 1 by 4. This is what the structure given. But in an isosceles triangle, there is a property that areas of two isosceles triangles are in ratio of their altitude squares. Are in the ratio of their altitude squares. Altitude 1 and altitude 2. Altitude 1 and altitude square. This is how the areas are related. What is an altitude? Altitude is the line drop or the perpendicular drop from the vertices to the opposite side, creating a 90-degree angle on the opposite side. So this is what is altitude. The another name for altitude is nothing but height itself. So we can write it down as h1 over h2's whole square. Okay, so clearly we have got a1 by a2 as h1 by h2 whole square, which is nothing but 1 by 4. So we can write here h1 by h2's whole square is nothing but 1 by 4. So there where we can find out h1 by h2 is simply under root of 1 by 4, which is nothing but 1 by 2. So that is the right answer. The ratio of their height is going to be 1:2. It is available in option number C, so becomes the right answer. Now, the radius of a circular garden is 7 meter more than the length of the rectangle whose perimeter is 364 meter and breadth is 84 meter. So clearly we need to follow the things sequentially so that we can get to it. So the first thing is say radius of a circular garden is 7 meter more. So the radius is 7 meter more, and then the length of a rectangle where, so we should relate to rectangle first because there is perimeter also given, there is breadth is also given. So let us do it like this. Perimeter of the rectangle is given as 364 meter, and breadth is given as, breadth of this rectangle is given as 84 meter. So clearly we can use the perimeter formula and find out the L using that. So perimeter of a rectangle is always given by 2 into L plus B. So perimeter is given as 364 is equal to twice of L value is unknown, L plus B value is already given, that is 84. So if you solve this, this comes out to be 2 can cut this 364 on the other side, this is 182. So L value is 182 minus 84, that is nothing but it comes out to be 98 meters. So the L of the perimeter, L of the rectangle has come, breadth is also available, length is also available. Now we can relate to the condition which is said that radius of a garden is 7 meter more than the length. So radius of the garden is 7 more than the length. This is the condition. So radius is equal to length is 98 plus 7, that is going to be 105. So radius of the circle or the circular garden is 105. This is what he was. So after that, what will be the cost of fencing the garden only at the if the cost of fencing is rupees 8 per meter. So fencing is done on the circumference. So we need to find out the circumference of the circle first. So circumference of a circle is given as 2 pi r. Let's put down our value of radius. So it's going to be 2 into 22 by 7 into radius value is 105. We can cut down this number. 7 1 is 7, 3, 7 5 is 50, 7 5 is 35. So the circumference value is coming out to be 660 meter. By that, he says that cost of fencing is 8 per meter. So for costing 1 meter, you need to spend 8 rupees. Okay, so we have to fence 660 meters, so we'll have to spend how much? It's clearly a unitary method, 660 into 8, that many rupees. So that is actually coming out equal to 5280 rupees. So that is the right answer. Fencing can be done at the cost of 5280 rupees, which is available in option number D. So it becomes the right answer there. Now he says, find the ratio of the percentage increase or decrease in the volume of a cone if its radius is doubled and its height is reduced to half. So this is what he's saying. Radius has been doubled and height is reduced to half. So let us say what is the volume of the cone first. Okay, we need to understand the volume of the cone first. Okay, so let's say the original volume. Let's say is the formula is given by 1 by 3 pi r square h. Okay, so this is the original volume with original radius r, original height h. Now he says the radius is double. So new radius is double the original radius. So that is 2r. Then similarly new height is nothing but height is reduced to half. So h by 2. So these are the new dimension, new radius and new height. Now with this new radius and new height, let us find out the the final volume. So the final volume is going to be again 1 by 3 pi r square h. So pi into, in place of r we'll put 2. So 2r square, in place of h we'll put h by 2. So this is what will be the final volume. Okay. If we solve this further, this comes out to be how much? This is coming out to be 2 by 3 pi r square h. So this is the final volume. This is the initial volume. Now he wants us to calculate, find the ratio of the percentage increase or decrease in the volume of a cone. So we need to find out the percentage decrease or increase. So first of all, we need to find out whether there has been increase or decrease. If you compare these two values, clearly this is 1 by 3 pi r square, this is 2 by 3. So obviously final volume has been more. So how much more? For that we need to find out that Okay, so the question says find the ratio of percentage increase or decrease in the volume of a cone if its radius is doubled and its height is reduced to half. So let us find out the volume or the original volume. That is, original volume of a cone is given by 1 by 3 pi r square. So this is going to be the original volume. Now let's see what changes he has done. He has doubled the ratio. He has doubled the radius. So new radius will be twice of the original one. That is 2r, and he has reduced the height to half. So we'll find out new height will be how much, will be the old height divided by 2, that is h by 2. So these are the new dimension that is there with us. Okay, now with this let us find out the new volume. Okay, the new volume will be, the formula will be same, 1 by 3 pi r square h. Pi, in place of r we'll put 2r square, and in place of h we'll put h by 2. So this is what we're going to do. Okay, if we simplify this to, this becomes nothing but 2 by 3 pi r square h. So this is the new volume, this is the older volume. Now what he is asking for, find the ratio of the percentage increase or decrease. So first of all we need to find out the increase, then we can convert that into percentage later on. So what is the increase or decrease? So let us see, this is 1 by 3 pi r square h, this is 2 by 3 pi r square. So clearly this one is doubled, so it has been more. So obviously there has been an increase. So how much is that increase? Increase can always be find out by final value minus the old value. So it's always 2 by 3 pi r square h minus 1 by 3 pi r square h. This is how the difference has been found out. Okay, which is, so we can find this out. So in this way we can say, if we subtract this 2 by 3 pi r square h minus 1 by 3 pi r square h. Okay, so it is, let's take something common. So it's going to be pi r square h over 3 is almost coming common. How much is left out? We are left out with 2 minus 1. So it's coming out to be 1 by 3 pi r square h. This much is coming 1 by 3 pi r square h. So now we need to find out the percentage increase. So percentage increase, for finding out the percentage increase, okay, we need to find out the percentage increase. Clearly percentage increase is always increase over the older value divided by multiplied by 100. Okay, so 1 by 3 pi r square has been there, so it has to be pi r square h divided by 1 by 3 pi r square h multiplied by 100. Okay, rather we have to put the other one up, so it has to be 1 by 3 pi r square h up by 3 pi r square h over pi r square h into 100, which is nothing but clearly cutting at as 300%. So that is the final value. It has been increased by 300%. Available in option number D becomes the right answer. Now, the height of a circular cylinder is increased 6 times and the base area is decreased to 1/9 of its value. Okay, these are the changes that has been done. The height of a circular cylinder is increased 6 times and the base area is reduced to base area is decreased to 1/9 of its value. The factor by which the lateral surface area of the cylinder will be increased, that's what we are supposed to calculate. Okay, so let us see the formula for the lateral surface area. Lateral surface area for a cylinder is always given by 2 pi RH. Okay, then he says, let's, if you see the shape of a cylinder, this is how a cylinder looks like. The base of a cylinder is always a circle. Base of a cylinder is always a circle. That's what he says. The base area is decreased to 1/9 of the 1/9 of its value. So original base area was obviously a circle, that is pi r square. New base area is now 1/9. So it is going to be 1 by 9 pi r square. So this is going to be the new base area. Okay, so if we relate this to the older base area, then we can find out what has been happening with the new radius. Let's say this older radius was r1, the new radius is r2. So we can clearly say that if you want to find out the ratio between this, so we can say pi r1 square divided by pi r2 square is clearly going to be 9:1, because that has been reduced to 1/9. So clearly this gives r1 by r2 is coming out to be 1 by 3, is coming out to be 3 by 1 rather, which gives r2 value as 1 by 3 of the r1. So what has happened with the radius? Radius has been reduced to 1/3 of it. Okay, because the base area has been reduced to 1/9, so radius has been reduced to 1/3 of it. So this is what is the new radius, r1 by 3, that is 1/3 of the old radius. We're going to use this. And what has happened with the height? He has said the height of a cylinder is 6 times. So the new height, let's say, is h, is 6 times the old height, that is 6h. So we'll use r2 as a new radius and capital H as the new height. Okay, so then new lateral surface area will be 2 pi rh. So it's going to be 2 pi. In place of r, we're going to put r by 3. In place of h, we're going to put 6h. So these are the value that we have transformed, which comes equal to 4 pi rh. So this is what is coming as the final little surface area, and the older surface area was 2 pi rh. So if we compare these two values, we can clearly say the final one is double the original one. So the factor that by which it has been increased or it had been changed is simply going to be 2. That is 2 times, which is available in option number A, becomes the right answer. Now, two sides of a triangle are of length 4 centimeter, 10 centimeter. If length of the third side is a centimeter, then which of the following is true? That's what we need to verify. So let us create the triangle first. This is how the triangle looks like. The sides are, let's say this is 4 centimeter. Let's say this is a. That's what he is assumed. And let's say this is 10. C equal to 10. We'll say C equal to 10 and B is equal to 4. This is how we have taken them. Okay. Now, if the length of the third side is a centimeter, that C is given. So we need to find out the ratio. So clearly there is a theorem that the third side is always lesser than sum of the other two sides. Okay, this is a theorem that third side of a triangle is always less than sum of other two sides. Sum of other two sides. This is what is a clear theorem. So in this case, we can clearly say that A is less than equal to B plus C. Okay, these are the two other sides. So let us put down the values. A is less than equal to B value we know is 4, C value we know is 10. So clearly A is less than 10. So A is clearly less than 10. This is what is the first conclusion that we drawn. Or in the same situation, in this particular expression, we can also evaluate that A is greater than C minus B. A is greater than C minus B. A is always greater than the difference of the two sides. This is another theorem that the third side is always greater than the difference of the other two sides. So A is greater than C minus B. So we can write A is greater than 10 minus 4, which is nothing but A is greater than 6. So we have got two conclusions for 6. One is this: A is less than 14 and A is greater than 6. So clearly A lies between 14 and 6. So that's what we can conclude out of these two, that A lies between 14 and 6. So this is how the final conclusion of our result is. So this is going to be the right answer that is available in option number D. It becomes the right answer there. Now, find the number of cubes that can be cut out of 4 cross 3 cross 2 meter cuboid if the carpenter wants to cut the largest possible cube. Okay, so this is what is the cuboid that is there available with us. This is what is the cuboid that is available with us. From this cuboid, let's do the inner light lines also. This is what is the cuboid. From this cuboid, the carpenter wants to cut down the cubes. So the dimensions are 4 cross 3 cross 2. So the cube that are to be cut, that can hold, the cube is always having the similar dimension of all the edges. So we have got three dimension, 4, 3 and 2. So the particular edge of that particular cube that you want to cut will be holding the smallest out of these three dimension, will be holding the smallest out of these three dimension, that is going to be 2. So clearly the cuboid that will be have to be cut will have a edge as 2 meter. So what will be the volume of that particular cuboid? Volume of the cube to be cut. So what will be the volume of cube to be cut? Will be simply, as the dimension is going to be 2, so volume of is always given by side cube, so it will be always 2 cube equal to 8 meter cube. So that will be the volume of the cube that is to be cut. What is the volume of our cuboid? Volume of our cuboid is, let us judge well, what is the volume of our cuboid? Volume of our cuboid is nothing but side cube again, but here the side are different because it is a cuboid, so it's going to be L into B into H. So let us put the values: 4 into 3 into 2, that is nothing but 24 meter cube. Okay, that is the volume of the cuboid. Now how many number? So number of cube to be cut, number of cubes that can be cut will be simply volume of the cuboid, the bigger cuboid, from it has to cut, divided by the volume of the cube that is to be cut, volume of the cube that is to be cut. If we put down the value, it's going to be 24 divided by 8, that is nothing but 3. So 3 are the 3 number of cubes can be cut from this particular cuboid. Let's see where it is available. It is available in option number C and becomes the right answer like that. Now the volume of a right circular cone is 1232 centimeter cube and its vertical height is 24 centimeter. Find its curved surface area. So clearly we have given some values. So we'll equate that to our formulas. The first thing is volume is 1232 centimeter. Volume is 1232 centimeter cube. Okay, so volume can be stated as volume of a cone is nothing but 1 by 3 pi r square h. This value is given as 1232. So we can put the values of radius, and the height is also given as 24 centimeter. So it's going to be 1 by 3 into 22 by 7 into r square into h value is 24 is equal to 1232. So clearly we need to solve for our r square. So r square is coming as, if we take everything on the other side, then obviously this 3 had also cut this 8 has also cut this 1 2 3 2. So r square is ultimately coming out to be 49, which gives us r value as 7. So the radius of 7 has come now, and he wants us to calculate the curved surface area. The formula for curved surface area of a cone is simply pi r L, where this L is the length, okay, where L is the inclined length, and which is given by under root of r square plus h square. L is the slanting or the inclined length, which is given by under root of r square plus h square. So let us find out L. So L is going to be under root of radius value is 7 square plus h value is 24 square, okay, which is going to be under root of 49 plus 576, which is nothing but under root of 625, which is the value as 25 centimeter. So L value has come out to be 25 centimeter. Now we are supposed to find the curved surface area, so we have to put the values of everything R and L in this formula. So if we do that, curved surface area is coming out to be 22 by 7 into radius value is 7 into L value is 25. So clearly this 7 and 7 cuts, 25 into 22, that's what we are supposed to find out, which is nothing but 550 centimeters square. So that is the curved surface area being asked in the question. Option number B becomes the right answer. Now, the area of a sector of a circle is 77 square centimeter, and the angle of the sector is 45-degree. Okay, so we can create it like that also. So let's say this is that very sector. Okay, the angle is 45-degree. The whole angle we know is 360-degree, and area of this particular sector is given as 77 centimeter. If we are supposed to find out this radius, let's say this radius is r. Okay, area of this particular sector is given as 77 centimeter square. Okay, so we are supposed to find out the for doing that, we can use the ratio of the, we can use the formula for the area of a sector in terms of the area of the circle. See, area of a sector is given by area of a sector is given by area of a sector is given by always theta divided by 360-degree into pi r square. Okay, where this theta is nothing but the angle that particular sector creates on the center. Okay, and pi r square is the area of the whole circle. So we can put the value, we know the angle, so it's going to be 45 divided by 360 into 22 by 7 as pi into r square, and this is equal to, the area is already given to us as 77 square centimeters. So clearly we need to solve this expression for our r square. We can cut down the values as much as possible. So we can cut it from here. 11 cuts 22 by 2 and 11 plus 77 by 7. Similarly, 45 can also be cut. So we can cut 45 by 5. So it's 5 9 ja 45, and it's going to be 72. So clearly we can cut down some more values. So ultimately r square comes out to be 77 into 7 into 8 divided by 22, which is ultimately reduced to r square value as 196, which gives r value as under root of 196, which is nothing but 14 centimeters. So that is the ultimate radius he was asking for, 14 centimeter. Option number B is right. Then he says a circular rod runs around a circular ground. Circular road runs around a circular ground. If the difference between the circumference of the outer circle and the inner circle is 66 meter, the width of the road is. This is what we are supposed to find out. So let's create the circle. These are the two circles. Okay, circular road runs around the circular ground. So this, the inside one is the ground, and this outside one is the, that very road he's talking about. The difference between the circumference of the outer and the inner is 66. So let us write down. Let us assume the radius of the outer circle is capital R, and let us assume the radius of the small circle is small r. So these are the two variables we have taken. So the circumference of the outer circle is going to be, circumference is given by 2 pi r. So it's going to be 2 pi capital R. Circumference of the inner circle will be going to be again 2 pi small r. He says the difference between them is 66. So let us do it. So 2 pi capital R minus 2 pi small r is 66. The difference is given like that. So obviously we can take the 2 pi as common. If we do that, r minus r becomes 66. So we are supposed to solve this r minus r. So r minus r is nothing but 66 divided by 2 pi. If you open 2 pi as 22 by 7, it's going to be 66 divided by 2 into 22 by 7, which makes it equal to 66 into 7 divided by 2 into 22. This 22 cuts this 66 exactly by 3. So ultimately it comes out to be 21 by 2. That is the difference of r minus r is 21 by 2 is nothing but 10.5 centimeter. What he had asked for, he has asked for the width of the road. So width of the road you see is nothing but the difference of the radius. So that is what is the road width of the road is 10.5 centimeter becomes the right answer available in option number D. Now, the perimeter of the base of a right circular cone is 8 centimeter. Okay, so let us create the cone first. This is the cone. The perimeter of a cone is always a circle. He says this perimeter of the circular cone. So, perimeter of a circle is nothing but called as circumference. So, clearly the circumference value of the cone is given out to be 8 centimeter. Okay, so the circumference of the cone is given out to be 8 centimeter. So, circumference of a circle is nothing but 2 pi r. So this 2 pi r is given out to be 8. So clearly we can using this we can find out the radius. So radius is going to be 8 divided by 2 pi, or we can write it as 4 by pi. Let's leave it like this only. Let's not solve it further because this is have to be reused in the next particular part of the question. Now the next part he says if the height of the cone is 21 centimeter, height is also given as 21 centimeter. So this is what is the height, which is he's saying 21, and the radius we have just calculated to be 4 by pi. Using these, he wants us to find out the volume. So volume, the formula of the volume of a cone is simply 1 by 3 pi r square h. We can put all the values inside. So it's going to be 1 by 3 into pi r square h. So it's going to be pi into r value is 4 by pi. So 4 by pi into 4 by 5 into h value is 21. So clearly we are supposed to solve this particular equation. Okay, if we solve this, pi and pi gets cancelled, then we can cut down some more values. 3 can cut this 27 by 7. So it's coming out to be actually 112 divided by pi centimeter cube. So that is what is the volume. Okay, because all the options are given in terms of pi only, so we don't need to solve this further. We'll keep it like that only. Volume is 112 by pi centimeter cube. Let's see where it is available. It is available in option number A. So it becomes the right answer there. Now, the diagonal of a cube is 6 root 3. The ratio of its total surface area and volume is how much? Okay, diagonal of a cube is given. So let us say diagonal of a cube is how much? Diagonal of a cube, the formula for diagonal of a cube is nothing but side root 3. The formula for the diagonal of a cube is nothing but side root 3, and this particular side root 3 value is given to us as 6 root 3. So clearly we can equate both the things. So side value is 6. By this we can understand the side value is nothing but 6 centimeters. So we have got the side of our cube. Now he wants us to calculate the ratio of its total surface area to volume. So let us create the ratio first. Okay, so total surface area of the cube is given as 6a square, that is 6 into side square. Volume is given by a cube. So the ratio will be simply 6a square divided by 6a cube. Okay, this will be the ultimate ratio. Okay, now if we solve this further, then 6 and 6 get cancelled and we are left out with 1 upon, we are left out with 1 upon a. That's what we are left out with. Okay, the 6a square, we are supposed to find out the total surface ratio of total surface area and its volume. Total surface area is given by 6a square and the volume is given by a cube. Volume is given by a cube, not 6a cube. It's given by a cube, so it has to be 6 by a. Okay, 6 by a would have been left out. Now we can put the value of a that we already calculated as 6 centimeters. So volume comes out to be this, rather in place of volume, this particular ratio is comes out to be 6 by 6, that is nothing but 1 by 1, that is 1 is to 1. So that is what is the ratio between total surface area and the volume, 1 is to 1. It is available in option number C, becomes the right answer. Now, if the volume of the sphere is divided by its surface area, we obtain 27 centimeters. So let us put the expression of volume of sphere. Volume of sphere is given by, volume of a sphere is given by 4 by 3 pi r cube. This is what is the volume of the sphere. Now, similarly, he has asked for the surface area. So surface area of a sphere is given by, surface area of a sphere is given by 4 pi r square. This is what is the surface area. Now, he has given this ratio to be 27. So let us put it down. 4 by 3 pi r cube divided by 4 pi r square has to be 27. So we can cut down for certain things. 4 can be get cancelled. Pi can get cancelled. 2 power of r can get cancelled. So only 1 power of r will be left out. So we are ultimately left out with 1 by 3 r is equal to 27, which can give us the value of the r. R value is nothing but 27 into 3. That is 81. Okay, so that is what is the radius value. 81 centimeter becomes the right answer. The perimeter of the base of a right circular cone is 8 centimeter. If the height of the cone is 21 centimeter, then its volume. Okay. Perimeter of a right circular cone. Perimeter of a right circular cone means the perimeter of the base. Okay. So this is how the cone looks like. So base of a cone is always a circle. So perimeter of a circle is nothing but the circumference of the circle. The circumference of the circle is given by 2 pi r, and which is given here as equal to 8 centimeter. So we can find out the radius using this. So radius can be calculated to be 8 divided by 2 pi, which is nothing but 4 by pi. So this is what is the radius of that particular cone is. Now further he has given the height of the cone is 21 centimeters. H value is 21 centimeters. Now we are supposed to find out the volume of this particular cone. So the volume of the cone is given by volume of the cone is always given by 1 by 3 pi r square h. We have got the r and h value and we can put it down here. So 1 by 3 pi into r value is 4 by pi. So we can write 4 by pi is whole square into h value is 21. So clearly we need to solve this particular expression, and see all the options are given in terms of pi only. So we don't need to put the value of pi in there. We can rather solve it using the value of pi as pi itself. So if we solve this further, this is ultimately coming out to be 112 by pi centimeter cube. So that is the right volume he had asked for. 112 centimeter pi centimeter cube becomes the right answer. Now, if three cubes of copper, each with an edge of 6, 8, and 10 respectively, are melted to form a single cube, then what is the diagonal of the new cube? So three cubes are there with different edges. So when these three cubes are melted, that means their volume is collectively collected together, and then with that particular volume of the metal, a new cube is being created. So first of all, we need to find out the volume that has been collected by adding the volume of each and every cube that is there. So let us find out the volume of the new cube will be nothing but volume of first cube plus volume of second cube plus volume of third cube. So volume of a cube is always given by one is always given by side cube. So let us find out the volume of the new cube is going to be volume of the cube with the side 6 centimeters. So it's going to be 6 cube plus volume of the cube with side 8 centimeter, 8 cubes, sir, plus volume of the cube of the side 10 centimeters. So it's going to be 10 cube. If we solve this further, this comes out to be 216 plus 512 plus 1000, and the sum becomes 1728. So this is the volume of the new cube. So we are supposed to find what is the diagonal of the new cube. So diagonal of a cube is always given by side root 3 or the edge root 3. So for finding out the diagonal of the new cube, we are supposed to know the side of the new cube. So side can be given as cube root of the volume. Side is always calculated for the cube as cube root of the volume. So we are supposed to find out the cube root of 1728. Okay, so which is coming out to be 1728 is the perfect cube of 12 centimeter. So the side of the cube becomes 12 centimeter. Then he wants us to calculate the diagonal, so we can put this side value here. So it's going to be 12 root 3. Because the options are given in all decimals, so clearly we need to solve this. So we need to put the value of root 3. The value of root 3 is 1.73. So it's going to be 12 into 1.73. If we solve this particularly, so this comes out to be 20.8 centimeter. So that is the volume of the diagonal. 20.8 centimeter becomes the right answer, option number C. The total surface area of a solid right circular cylinder is twice that of the solid sphere. So let us establish this connection first. Surface area of a right circular cylinder is twice that of a solid sphere. So let us know what is the surface area of a cylinder. Surface area of a cylinder is given by 2 pi r h plus r. This is what is the surface area of the right circular cylinder is given as. What about the solid sphere? the total surface area of the solid sphere. So surface area, let's say total surface area of the sphere. Total surface area of the sphere is given by 4 pi r square. So these are the two things that we know. Then he said that if they have the same radius, so the radius of both the things are same, both the objects are same, so r can be treated as it is. So he wants us to calculate the ratio of the cylinder, ratio of the volume of those two particular objects. So first of all, we'll put that condition that he says the surface area of the cylinder is equal to twice of surface area of the sphere. First of all, we'll solve this. Okay, so surface area of the surface area of the cylinder, so that is nothing but 2 pi r h plus r is equal to twice of surface area of the sphere, that is 2 into 4 pi r square. So we can cut down few numbers like this. 2 can cut this 2. So an r, this r and pi can also get cancelled. This pi get cancelled by this r 1 power get cancelled by this. So ultimately we are left out with h plus r is equal to 4r, which gives us h value as 3r. So this is what is the connection that we know between h and 3r, h and r, that is h equal to 3r. Now we have to find out what? We have to find out the ratio of the volume of the cylinder to sphere. So we need to find out volume of cylinder divided by volume of sphere. This is what we are supposed to find it out here. Let us put down the let us write the formulas first. Volume of a cylinder is given by pi r square h, while volume of the sphere is given by 4 by 3 pi r cube. So we can cut down few things as the radius is same. So the complete r square can go on and 1 power of r will be left out. Pi will also be cancelled. So we'll ultimately left out with this ratio will be left out as ultimately uh, and if we put the values also, so this is coming out to pi is also get cancelled, h divided by 4 by 3r, so it's going to be 3h by 4r. This will be the ultimate ratio. If we put the values of h as 3r, then it is going to be 3 into 3r divided by 4 into r. Okay, so if we cut down the numbers, so r and r get cancelled, so ultimately this is coming as 9 by 4. So that is the ratio of the volume is coming as 9:4. That becomes the right answer available in option number A. Now, if the diameter of a circle is doubled, its area will become what? Okay, so let us find out the old area. Let the old area of a circle is circle 1 is circle's area is always given by pi r square. He's saying the diameter is doubled. So diameter is nothing but 2r. So the let's say the original diameter was 2r. That's why the radius was d by 2. Okay. Now the new diameter is double. So the new diameter is going to be twice of d. So d is always twice of r. It's going to be 2 into 2r. That is nothing but 4r. So the new radius is now the new diameter is 4r. So what is the new radius? Let's say r2. Let's name them as r2 and r2, and this is r1 and r1. So the new radius is going to be always diameter divided by 2. Diameter divided by 2. Diameter is coming out to be 4r2. So 4r2 divided by 2, that is nothing but 2r2. So the radius is also get doubled. So if the diameter is doubled, radius is also doubled. Then he wants us to calculate what will happen with the area. So the new area C2 will be again pi r square only. Pi into new radius is now twice of the older radius. So 2r's whole square. Okay, if you solve this further, this comes out to be 4 pi r square. Okay, so this is the new area 4 pi r square. The original area was r pi r square. So he says the area will become how much? So clearly we can see the area has become 4 times. So that's going to be the right answer, option number D, 4 times. Now, how many bricks will be required to construct a wall measuring 13.5 meter long, 6 meter high, and 22.5 centimeter thick if each brick measures 27 centimeter into 12 centimeter into 9 centimeter? So clearly the bricks are of the shape of cuboid. Always the bricks are of the shape of cuboid only. So this is what is that cuboid. The bricks, if we talk about bricks, the dimensions are 27 long, then 12.5 breadth and height is 9 centimeter. These are the dimension of the brick, and the wall that is to be constructed wall has got a dimension as 13.5. Let's say this is the big wall. Okay, then let us say this is the big wall that is to be constructed like this. Okay, this big wall has got the dimension as 13.5 meter long, 6 meter high. So 6 meter is high and 22.5 centimeter 6. So these are the dimension like that. Now he wants us to calculate how many bricks will be required. So clearly the number of bricks can be calculated by the division of the volume of the structures. So number of bricks that are required for this thing is volume of the wall divided by volume of each brick, volume of each brick. So let us find out. Volume of a cuboid is always given by L into B into H. So it's going to be, let's write it here, volume of a cuboid. This is the wall is of a shape of a cuboid and brick is also a shape of a cuboid, is always given by L into B into H. So we're going to use this formula only for both the things. So volume of a wall can be the multiplication of all those terms. 27 into 12, volume of wall is going to be rather 13.5 into, let's do it here, will be 13.5 into 6 into 22.5 centimeter. Now the wall is, the thickness is given in centimeter, so we need to convert everything into centimeter. So 135 was in meter, so we need to multiply 100 so that the 135 converts into centimeter. Now the 13.5 converts into centimeter. 6 was also in meter, so we need to multiply again by 100 so that this 6 is converted to centimeter. 22.5 was already in centimeter, so this is what we have done. Now volume of one brick. Okay, all the dimension of the brick are given in centimeter only, so we don't need to convert. So it's going to be 27 into 12.5 into 9. Okay, so if we solve this further, the volume of the numerator comes out to be 18,225,000 and the denominator comes out to be 3037.5. If we divide together, then this comes out to be exactly 6,000 bricks. So there can be 6,000 bricks that can be used to construct that particular wall over there. Now, how long will a child take to cross a square park diagonally at 3.6 kilometer per hour if the area of the park is 31,250 square meters? So let's say this is that particular square park. The area is given out to be 31,250 meters square, and the child has to cross it diagonally. So clearly we need to know the diagonal length. Then only we can find out how long will it take, how much time it will take. So speed is given, the time we are supposed to calculate, and distance can be calculated from the mensuration part. Okay, so distance is nothing but the distance of the diagonal. So clearly we need to find out the diagonal of this particular square. Okay, so area of the square is given as side square, that is a square is given as 31250. So this is what is the area. So clearly the side will value will be under root of 31,250. This will be the side, each side value under root of 31,250. Now diagonal of a square is given by always side root 2. Diagonal of a square is always given by side root 2. So diagonal of this square will be also side root 2, that is under root of 31,250 into under root of 2. Okay, this can be done by multiplying the things inside. So it's going to be 62,500. If we solve this further, diagonal is going to be the under root of 62,500, that is nothing but 250. Okay, so that is the length of the diagonal that is there. Now this diagonal length 250 meter. Now clearly we have got a distance value as 250 meter, that's to be traveled by the child. The speed value of the child, speed is given as 3.6 kilometer per hour. Okay, so we can convert this speed into meter per second by multiplying it by 5 by 18. So speed is given by 3.6 into 5 by 18. This 5 by 18 is a factor that can convert 1 kilometer per hour into meter per second. So this is how this is done, 3.6 into 5 by 18. This is the speed. Now we know speed is equal to distance over time. So clearly time is equal to distance over speed. So that's what we are supposed to calculate. How long means the time. So time is equal to distance value is 250 divided by the speed value is 3.6 into 5 by 18. 18 goes up. So clearly we need to solve this particular expression, and that can calculate the time value. So time value comes out to be 250 seconds. So this is the right answer. Time value, how much time it will take? It will take, the child will take 250 seconds in all. Now, find the surface area of a tile with the dimension this, this, and this. The surface area of a tile. So clearly, the tile is in the shape of a cuboid. Okay, the tile is in the shape of a cuboid who has got a thickness also, the length also, and the breadth also. So these are the shape of the tile. So it can be said length into breadth into breadth. height, so 0.09 into 7 into height is 5.8. This is how the dimensions are there. We are supposed to find out the surface area. So we need to know the formula of the surface area first. Surface area of a cuboid, because the tile is in the shape of a cuboid, so surface area of a cuboid is always given by twice of LB plus BH plus HL. This is how the surface area is given as. So let us put down the values inside. Twice of L value is 0.09 into breadth value is, okay, so length value is 0.09 meters. Okay, length value is 0.09 meter. Rest of the values are given in centimeters. So clearly we need to convert this meter into centimeter to match with everything. So 1 meter has got 100 centimeter. So 0.09 meter will get 0.09 into 100, that is nothing but 9 centimeter. Okay, so this particular length is nothing but 9 centimeter. So in place of 0.09 in place of the 0.09, we will keep it as twice of 9 centimeter. So it's going to be twice of, okay, so the question says find the surface area of a tile with dimension 0.09 meter, 7 centimeter and 5.8 centimeter. So clearly rest of the two dimensions are in centimeter, but the first one is in meter. So clearly we need to convert this first into the centimeter. So if we do this, 1 meter has got 100 centimeter, 1 meter has got 100 centimeter. We have got here 0.09 meter. So 0.09 meter will be nothing but 0.09 into 100, that is 9 centimeter. So clearly this particular dimension is 9 centimeter. Now he wants us to find out the surface area of a tile. So this is the dimensions. A tile is always in a shape of a cuboid. A tile is always in a shape of a cuboid. So the dimensions are given with us. So the surface area of a cuboid is given by 2 times LB plus BH plus HL. Let us put down the values. We have been given L as 9 centimeter. This is our L, this is our B, and this is our H, sequentially L, B, and H. So it's going to be 2 times L value is 9, B value is 7, plus B value is 7, height value is 5.8, plus L value is 9 and height value is 5.8. So this is what it is, has to be this. So now if we solve this further, this is going to be 2 times 63 plus this is 40.6 plus this is 52.2. If we solve this further, this comes out to be twice of 155.8, which is nothing but 311.6 centimeter square. So that is the right answer. The total surface area for this particular tile is 311.6 centimeter square. It is available in option number D. Now the length of a rectangular blackboard is 15 centimeter more than that of its breadth. So let's first of all take this as, let the length, rather the length is related to breadth, so let us assume the breadth. Let the breadth of blackboard, that is a rectangular blackboard is, let's say, B. So the length will be, he said that length is 15 centimeter more, so length will be how much? 15 plus B. Now if its length is increased by 9 centimeter and its breadth is decreased by 6 centimeter, its area remains unchanged. So the new length will be, he says the length is increased by 9. So new length will be older length, that is 15 plus B plus 9, that is nothing but 24 plus 9, 24 plus B, that will be the new length. Similarly, this was new length. Now let us find out new breadth. He says the breadth is decreased by 6 centimeters. So new breadth will be older breadth minus 6. Older breadth was B, so it has to be B minus 6. So these are the new dimension, new length and new breadth. Old length and old breadth are these. Now we are supposed to find out, he's saying that the area remains unchanged. So what we're going to do, we're going to find out the area in the first, with the first dimension set, and then area with the second dimension set, and then we'll make it equal because he says the area remains unchanged. So area with the first dimension set is going to be B into 15 plus B, because area of a rectangle is always given by L into B. So that's why it is B into 15 plus B is equal to, the new dimension is 224 plus B multiplied by B minus 6. So clearly we have to solve this particular expression to get the value of our B. So if we multiply, this is going to be 15B plus B square is equal to 24B minus 144 plus B square minus 6B. We have product. We have done the product part. So clearly this B square and B square gets cancelled on both the sides. 24 minus 6B is 18B. So 24 minus 6b is 18b minus 15b. This is how it has to come. So if we solve this finally, then we can find out the b value. So if you solve this finally, the b value is ultimately coming out to be 48 centimeter by solving this expression. Now if b value is 48 centimeter, he said the length is 15 more than b. This is where he said it. So length has to be 15 more than 48. If you solve this, this is nothing but 63 centimeters. So the length is 63 centimeter and the breadth value is 48 centimeter. Let us see where it is available. It is available in option number A. So it becomes the right answer. Now, the maximum length of a pencil that can be kept in a rectangular box of dimension 8, 6 and 2 centimeter is. So there is a rectangular box. This is how a rectangular box looks like. Okay, this is a rectangular box. Okay, and the space is rectangle, but actually it is a cuboid. Okay, that's why the dimension are 3 in number, L, B and H. So L, B and H, these are the 3 dimension looking like that. Now, we want to calculate that the maximum length of pencil that can be kept. So maximum length of a pencil can be simply the diagonal. Okay, so we are actually supposed to we actually want to calculate the diagonal length. That will only be the maximum length of pencil that can be kept inside. So length of a diagonal of a cuboid is given by under root of L square plus B square plus H square. That is the length of a diagonal of a cuboid. Formula is. So we have got all the values. So let us keep the values inside. It's going to be 8 square plus 6 square plus 2 square. If you solve this further, this is going to be under root of 104. Diagonal is going to be 100 to 104, which is nothing but is equal to under root of, we can break this as 4 into 26. If you bring it down further, this comes out to be 2 root 26 centimeters. So that is the final answer. This is the length of the pencil of maximum length that can be kept inside this box. That is the right answer. Now, the perimeter of a right angle triangle measures 234 meter. Okay, and its hypotenuse measures 97 meters. So let's make a right triangle. Okay, this is a right angle triangle. He says the perimeter is 234 and the hypotenuse is 97. So let us assume the sides as this is the side A. So what will be the another side? So let us find out the sum of these two sides. See, perimeter value is nothing but sum of all the three sides. That is side A plus side B plus the hypotenuse. Okay, that is nothing but A plus B plus hypotenuse value is 97 meter and the perimeter is already given to be 234 meters. So there where we can find out the sum of the other two sides is nothing but 234 minus 97, that is nothing but 137. So the first side is of 137 meters. So another side is, we can assume it like that. So A value is 137 meter. So B value can be taken as not rather B, but we can write this as 137 minus A because ultimately the sum is 137. Okay, now these are the sides we have got 97, 130, 97, then A, and the last one is 137 minus A. These are the three sides. This is a right triangle, so clearly we can apply the Pythagoras theorem here. Clearly we can apply the Pythagoras theorem here. If we do this, then Pythagoras theorem says hypotenuse square is equal to base square plus perpendicular square. So what is the base here? Hypotenuse is going to be your 97 as it is given. So this is going to be a square and the other side, that is a square plus the other side is 137 minus a whole square. So this will give us an expression by solving which we can get to the right answer. So let us try to solve this expression. So 97 square is nothing but 9409 is equal to a square plus 137 square is 18796. Okay, plus a square minus 274a. Solving this further down, so we are in a state of equation which says a square minus 137a plus 4680 is equal to 0. Solving this equation by factors or by Sridharacharya formula, we can get to the final factors as a minus 72 and a minus 65. So there can be two values of a coming. A value is 65. If a value is 65, the side B was 137 minus a. So it had to be 137 minus 65, which is 72. And other way around, if a we take as 72, that B will come out to be 65. So anyway, the two sides will be 65 and 72 only. That's what he asked for. The other two sides of the triangle are, so the two sides are 72 and 65 meter. So it becomes the right answer there. Now, the height of a Now he says the height of a right prism with a square base is 15 centimeters. So there is a prism that has got a base of a square and height of this particular prism is given out to be 15 centimeter. Okay, this is how the prism is shaped. This is how the height is. So we can join these all sides to the prism, and then the prism can be actually created in a 3D. So if the area of the total surface of the prism is 608 square centimeter, then its volume is. So clearly we can use the total surface area of a prism formula. What is that? Total surface area of a prism, okay, of a prism can be given as twice of area of the base, twice of area of the base plus perimeter of the base into the height. This is what is the formula, twice of area of the base plus perimeter into the height. So now let us see, the total surface area of the prism is already given to us as 608. So it is equal to twice of area of the base. He has already said that square base, the area, the height of a right prism is 15 centimeter. The base is in a square shape, and square has got an area of got an area of side square. That is the square's area. So in place of area of the base, we will write it as twice of side square. Okay, we'll write it as twice of side square plus perimeter into height. So perimeter of a square is nothing but 4 times the side. Okay, perimeter of a square is nothing but 4 times the side. So in place of perimeter, we'll write what? 4 times the side and multiplied by the height. So height is already given to us as 15 centimeters. So we'll write 15 here. So clearly we need to solve this particular equation for side. Let us assume the side as x. Then we can frame the equation in form of x. Let us do that. So it's going to be 608 is equal to twice of x square plus 4x into 15. So if we solve this further, this actually comes out to be so it is 608 is equal to 2x square plus 60x. So we can simplify this and get the equation as x square plus 30x minus 304 is equal to 0. This is the equation to be solved. This can be solved using Sridharacharya or prime factorization, anything. So if we use the Sridharacharya formula says x is equal to minus b plus minus under root b square minus 4ac upon 2a. Here we have got the a value as 1, b value as 30, and c value as minus 304. So if you put down the value, the x value can be calculated as minus 30 plus minus under root b square, that is 30 square, minus 4 into 1 into c value is 304. Okay, b square minus 4ac, and minus minus becomes plus, so it will be getting plus 4ac divided by 2a, that is 2 into 1. So if we solve this further, there are two values of x coming. One is minus 15 plus 23, and another one will be minus 15 minus 23. So if we do minus 15 minus 23, the x will come out to be negative, which is not possible because we are dealing in the dimensions. So if you do minus 15 plus 23, it will come out to be minus 15 plus 23 will give you as 8. So that is the value of x. X was nothing but assumed to be side. So the value of the side of this particular prism is going to be 6 centimeter. Now he asked us to calculate the volume. So the side value has come out to be 6 centimeter. He wants us to calculate the volume. Volume of a cube can be given by volume of a prism is given by, there's a formula for that. The formula is area of the base into the height. So area of the base can be calculated as side square. Side is 6. So its side is come out to be 8 rather. Side has come out to be 8. So it has to be 8 square multiplied by height was given to be 15. So if you calculate this further, this is going to be 64 into 15, which is nothing but 960 centimeter cube. So that is the right volume of the prism, 960 centimeter cube. It is available in option number C. Now, the exterior angle of a regular octagon measures. So we need to know the value, the formula for the exterior angle of any polygon first. So exterior angle of a polygon, of a rather a regular polygon. Regular polygon is a polygon where all the sides are equal. Regular polygon is nothing but, the exterior angle formula for the regular polygon is nothing but 360 divided by n, where this n is the sides of the polygon. So here we have got an octagon. An octagon has got 8 sides. So n value for the case of octagon, the n value is 8. So the same exterior angle can be calculated for octagon is, exterior angle for an octagon can be calculated by 360 divided by 8, which is nothing but 45 degree. So that becomes the answer, 45 degree. Option C. Now, a solid cube just gets completely immersed in water when 0.2 kg mass is placed on it. If the mass is removed, the cube is 2 centimeter above the water level. What is the length of each side of the cube? So clearly, whenever there is a mass, whenever there is a when a zero point 0.2 kg mass is placed on it, so whatever mass value is placed on a cube, so the volume replaced of the water is actually related to the mass. Okay, volume of the water replaced or removed because the weight is put on the cube or weight is put on the solid. That particular removed or replaced mass is actually removed or replaced volume is actually related to the weight. Okay, so we're gonna use this thing only to find out our thing. Okay, so the question says a solid cube just gets completely immersed in water when zero point 0.2 kg mass is placed on it. If the mass is removed, the cube is 2 centimeter above the water level. What is the length of each side of the cube? Okay, so there is a water level inside a particular tank or something. So he says when the cube is above it, then when the cube is completely above it, when there is no weight placed, but whenever there is a weight of 0.2 kg is placed over it, weight of 0.2 kg is placed over it, then cube is immersed inside that water, and when it is removed, it is 2 centimeter above the water level. So that means the depth it had taken, whenever the weight of zero point 0.2 kg is placed over it, the depth till which this cube has gone immersed is, he's saying, is 2 centimeters. So we can treat this as the height of the cube, height of the volume of the water that has been displaced by the weight of 0.2 kg. This can be understood like that. So we can take that the height of that particular volume, height of the volume of the water displaced, height of the volume of the water displaced can be simply taken as 2 centimeter. Okay, and length and breadth of the cube is will be taken as the other ones. Okay, so that is not given. So let us assume, let's say the cube has got a length of, cube has a get a let it is a cube, so it has to be a complete side. Let the cube side is equal to a. So we can calculate the volume of the water replaced. So we can calculate the volume of the water replaced. Volume of the water replaced, obviously the volume will be, the water replaced will be in the shape of cube only. So volume of the water will be side cube, or rather side cube here, side cube. Okay, and volume of the water replaced will be, see, when the volume of the water replaced here will be, now the that particular water displaced will be in the form of cuboid, so that the length and breadth, the product of length and breadth is already as side square, that is a into a, this will be the length into breadth into height, and height is nothing but 2 centimeter, height is nothing but 2 centimeters. So this is how it can be taken like this. So that is what is becoming equal to 2a square. So this is the volume of the water displaced by the weight of 0.2 kg when placed over a cube. Now what is that volume of the cube given as? Okay, so let us find out the volume, let us find out the weight. The weight given is 0.2 kg. So let us convert this into 1000 into grams. So 1 kg has got 1000 grams, so 0.2 kg has got zero point 0.2 into 1000, that is nothing but 200 grams. So clearly 200 gram of waste is displaced, 200 gram of weight is kept over the cube, then water of the volume of 2a square unit cube has been displaced, and these two things are always related. Volume is displaced only because of the weight is kept, so we can clearly relate to these two things. So this 2a square is equal to 200 grams. So we can find out the a value. So a value can be found out, a square is 100, so a value can be simply 10 centimeters. So that is the side of that particular cube over which the weight of 0.2 kg was kept. Side of the cube value has come out to be 10 centimeter. Now, the base of a solid prism is a right triangle. Okay, so the base is a right triangle. Let's draw it like that. This is what is the base. Okay, and the sides are 9, 12, and 15. So obviously 9 and 12 will be the other sides, and 15, the largest side, will be the hypotenuse only. Okay, the height of the prism is 5 centimeters. So this is a 2D figure. So let's say that this is the height. Height of the prism is given as height of the prism is given as 5 centimeter. Okay, this is what is the height. This has to be explained. This has to be understood in a 3D form. This is the height. This is how the prism goes up. Okay. Now he says the height of the prism is uh, 5 centimeter as already given. Then he says then the total surface area of the prism is to be calculated. So we need to first of all know what is the formula for total surface area of the prism. Total surface area of a prism. Okay, prism of the shape of any base can be given by. Okay, so the question says base of a solid prism is a right triangle whose sides are 9 centimeter, 12 centimeter, and 15 centimeter. So this is the base of the prism is 90 degree, 9, 12, and 15. So clearly 9 and 12 will be the other sides and 15 will be the hypotenuse, the longest side. And this is a prism created. The height of the prism is 5 centimeters. So this is like a 3D figure. So this has to go, the prism has to look like something this, and the total height of the prism has been given as 5 centimeter. Okay, then the total surface area of the prism is, so we need to know the formula of total surface area of the prism first. So total surface area of a prism is given by twice of area of the base, twice of area of the base plus perimeter into height, plus perimeter into height, where perimeter is the perimeter of the base. So let us find out this. Twice to the area of the base. Base is a right angle triangle, so whose area we can easily find out. So the sides are given to us. The sides are 9, 12, and 15. So we are supposed to find out base of the area of the base. So area of the right triangle is always given by area of a right angle triangle. Area of a right angle triangle is always given by, right triangle is given by half of base into height. This is with all the triangles also. So we know the base and we know the height. So it's going to be twice of half of base is 12 into height is 9. Okay, then plus perimeter into height. So perimeter of the base we need to calculate. So this, all the sides are given 9, 12, and 15. So the perimeter is obviously the sum of all the sides, 9 plus 12 plus 15, and multiplied by height. Height of the prism is given as 5 centimeters. So clearly we are supposed to solve this. So this is going to be twice of 54. 2 into 54 plus 12 plus 9, 21 plus 15, 36 into 5 is going to be 720. So it's 108 plus 720, that is nothing but 288 centimeter square. So that is the total surface area of the prism as asked in the question. It is available in option number C, becomes the right answer. Now, what is the height of cylindrical vessel, cross-sectional area 100 centimeter square to contain 50 liters of water? So first of all, let us know how much volume of the water is there. Volume of the water is given as, volume of the water is given as 50 liters. So we need to convert this into meter cube or the centimeter cube rather, so that we can actually equate this to the volume of the cylindrical vessel created from the left hand side. So let us find out. So there is a conversion factor. 1 liter is equal to 1000 centimeter cube. So we have got 50 liters. So 50 liter will be equal to 50 into 1000 centimeter cube. That much volume, which is nothing but 50,000 centimeter cube. This is nothing but 57,000 centimeter cube. So this is the volume of the particular water is there, which can be contained in this. So this is the volume of the cylindrical vessel also, because the water is contained in the vessel itself. Now let's see what is the cross sectional area. So this is how the cylinder looks like. The cross sectional area is also already given to us. The cross sectional area is 100 centimeters square. So volume of the cylinder can be calculated as cross sectional area multiplied by the height. So what is the cross sectional area? It is 100 into multiplied by height. Height has to be given, that is to be calculated. So let's say height is unknown. So this is the volume of the cylinder, and see, volume of the cylinder will be obviously equal to the volume calculated by 50 liters. So it's going to be 50,000 is equal to 100 into h, so which will give us h value as 50,000 into 100, which is nothing but 500 centimeters. So that is the height of the cylinder is 500 centimeter. The options are given in meters, so we need to convert this. So 1 meter has got 100 centimeters. So 500 centimeter will be there in just simply 5 meter. So that's going to be the right answer. Height of the cylinder is nothing but 5 meter, option number B. Now it says diagonal of a square is 4 root 2 centimeter. the diagonal of another square whose area is double that of the first square is. So clearly the diagonal of a square is given, diagonal of square 1 is given to us as 4 root 2 centimeters. So let us try to find out the side of this particular square so that we can find out the area, and then we can then we can find the area of the other square and things like that. So what is the formula for diagonal of a square is always side root 2, and the side root 2 value is nothing but 4 root 2. So clearly we can say the side value is 4 centimeter. So let us find out the area of this particular square. Area of S1 is nothing but side square. Area of the is equal to side square, that is going to be 4 square, that is equal to 16 centimeter square. So this is the area of the that particular square is 16 centimeter square. Now he says diagonal of another square is to be found out whose area is double of the first square. So area of the second square is twice the area of the first square. This is what has been said. So that is equal to twice of area of the first square is 16. So it's equal to 32 centimeter square. So this is the area of the second square is 32 centimeter square. Now he wants us to calculate the diagonal of the second square. For that we need to know the side of the second square. So clearly side of the second square will be simply root of the area, that is root of 32. Okay, we need to find out the root of 32, which is nothing but root of this 32 can be broken down as 16 into 2. So the area comes out so the side value comes out to be 4 root 2 centimeter. So that is the side of the second square is. Now he wants us to calculate the diagonal of the second square, that can be founded as root 2 into the side of the second square. So let us multiply the side of the second square by root 2. So it's going to be root 2 into 24 root 2, which is nothing but 24 into 2. That is to be calculated side root 2, 24 into 2. So this is what is coming out to be 24. So 32, 24 root 2, rather this was not 24 root 2, this was just simply 4 root 2. So it has to be simply 4 root 2, which is nothing but 4 into 2, that is nothing but 8 centimeter. So that is what is the diagonal of the second square is 8 centimeter. Here goes the answer. Now find the area of a rhombus whose diagonal measure 23 centimeter and 20 centimeter. We have to find out the area. So area of a rhombus in terms of its diagonals. Okay, area of a rhombus in terms of a diagonal is given by half of product of diagonals. Half of product of the diagonals. This is how the area is given by half of product of diagonals. So it's going to be half of the diagonals are 23 into 20. So that is nothing but 46. 23 into 20 divided by 2. That is nothing but 23 into 10. That is 230 centimeter square. So this is what is the area of the rhombus is 230 centimeter square. It is available in option number B, becomes the right answer. Now he says find the total surface area of a prism with a square base. So we have got a prism whose base is square. So this is how the prism would have been. Okay, we have got a prism whose base is a square and measures whose side measures 2 meter and the height of the prism is 5. So we can say this particular height is 5 meter and the side of the square base is 2 meter. So we need to find out the total surface area. So we need to know the formula of total surface area of a prism. Total surface area of a prism is given by, the formula is twice of area of the base, twice of area of the base multiplied by add plus lateral surface area plus the lateral surface area. Okay, where the lateral surface area can be also calculated. So the total surface area of the prism is by twice of area of the base. Base of this particular prism is a square where the side is given as 2. So it has to be 2 into 2 square, that is the twice of the area of the base plus lateral surface area. Lateral surface area is given by, so lateral surface area can be calculated by the side of the base is 2. So it has to be 2 square. This has to be 2 square into 2 into 5. Okay, whereas the 2 is the height, where the lateral surface area is given by twice of area of the base multiplied by height. So this is what has been used here, twice of area of the base, then multiplied by the height. The area of the base is 2 square, then twice, and then the height. So let us solve this. So by solving we can get this as, this is 8 plus 40, which is nothing but 48 meters square. So that is the ultimate total surface area being asked, 48 meters square. It is available in option number C, so becomes the right answer there. Now he says If the diagonals of the rhombus are of measure 12 centimeter and 16 centimeter, then the measure of its side is, okay, the diagonals are already given to us. We are supposed to measure the side. So the side can be measured if we can calculate the perimeter, because perimeters and diagonals are directly related. Similarly, the perimeters and sides are also directly equated. So the strategy is to find out the perimeter first, and then using the perimeter we can find the side. So perimeter of a rhombus, let us find out that perimeter of a rhombus is given by, perimeter of rhombus is given by twice of under root d1 square plus d2 square, where this d1 and d2 are nothing but the diagonals of the rhombus. So this formula can be used here so that the calculations can be easy. So perimeter of the rhombus P, let's say, is given by twice of under root of 12 square plus 16 square. This is how it can be calculated. So it is coming out to be twice of under root 12 square is 144 plus 16 square is 256, which comes out to be under root of 400. So it's going to be twice of under root of 400. Under root of 400 is nothing but 2. So it's going to be 2 into 20. That is nothing but 40 centimeters. So that is the actual parameter. Now, the rhombus looks like this. The rhombus has got a property that all the four sides are equal, A, and A. And the perimeter has come out to be 40 centimeter. So each side will be simply perimeter divided by 4, that is 40 divided by 4, giving you 10 centimeter. So that is the right answer. Perimeter value is 10 centimeter, available in option number A, becomes the right answer. Okay, find the lateral surface area of a cone formed by folding a semicircle of radius 6 centimeter. Okay, we have to find the lateral surface area of a cone formed by folding a semicircle. So whenever a semicircle like this is folded like this from this end to this end, then a cone is formed like this. Okay, then a cone is formed like this. So in this very cone, if we can notice that this particular radius, the center is this, so this particular radius are actually becoming the slant heights. These particular radius are actually becoming the slant height of the cone. Okay, so we can write that radius of semicircle is equal to slant height, of the cone. Okay, this is what we can understand by observation. Now the lateral surface cone formed by folding a semicircle, radius given is 6 centimeter. So 6 is equal to slant height of the cone is also, slant height of the cone is nothing but 6 centimeter only. That is what is given. Now let us find out what, and one more thing, the circumference of the semicircle will be, see, the circumference of this semicircle, this very part actually becomes the circumference of the base of the cone. We can write down here circumference of the circumference of the semicircle actually becomes the circumference of base of the cone, circumference of base of the cone. And this is how it goes. So now circumference of the semicircle can be calculated by, circumference of a semicircle is always given by pi r. So this pi r is equal to base of the cone. Okay, so base of the cone is again a circle, circumference of the base. Okay, so that is again a circle. So that is going to be 2 pi r, that is 2 into pi into 6 centimeter. This is how we can calculate. This pi and pi gets cancelled. So that's what we can say the lateral surface area of the cone can be calculated by pi r square, because that is ultimately a circle. That is equal to 22 by 7 into radius value is 6 into 6. So if we solve this further, this comes out to be simply 133 centimeter square. This comes out to be 133 centimeter square. Let's see where this is available. Okay, so he says find the lateral surface area of a cone formed by folding a semicircle of radius 6 centimeter. So whenever you have a semicircle like this and there is a center in there, so these are the radius of the semicircle. Whenever the semicircle is folded like this, so that this particular edge joins this edge, then you get a shape of a cone like this. Okay, then you get a shape of a cone like this. Now if you can observe, the radius of this semicircle actually becomes the slant height of the cone both ways. And similarly, the circumference of the base of the cone is actually formed by the circumference of the semicircle. So we got two conclusions. First one is that the radius, first conclusion is radius of the semicircle, that was folded later on is equal to slant height, that is equal to slant height of the cone, slant height of the cone. So radius of the semicircle is becoming slant height of the cone, which is represented by L. So clearly R is equal to L. R of the semicircle is equal to L of the cone, which is 6, because the radius of the semicircle is given out to be 6. So length, slant height of the cone becomes 6 centimeters. The first thing. Next observation that we can notice is that the circumference of the semicircle actually becomes circumference of the base of the cone, okay, which is circle. So circumference of the semicircle is given by pi r s. S for the semicircle is equal to circumference of the base of the cone is a full circle. So it is given by 2 pi r c. So we can find out some value. Pi can be cut by pi. Rs value is already given as 6. So 6 is equal to 2rc, which gives the radius of the cone value as 3 centimeter. Now the radius of the cone that we have is 3 centimeter. Slant height of the cone is already calculated to be 6 centimeter. He wants us to calculate the lateral surface area of the cone. So the formula for lateral surface area of the cone is simply pi RL. So let us put down all the values. Pi is 22 by 7. Radius of the cone is 3. Slant height of the cone is 6 centimeter. If we solve this further, this becomes 18 into 22 by 7, which comes out to be approximately equal to 56.7 centimeter square. So that becomes the right answer. The lateral surface area of the cone being asked is 56.7 centimeter square. It is available in option number B. Now, a well of inner diameter 14 meter is dug to a depth of 15 meter. Earth taken out of it, earth means soil, it had been evenly spread all around to a width of 7 meter to form an embankment. Find the height of the embankment so formed. So what has happened is, see, there's a well like this, and it has got a inner diameter like this. This has the wall. These are the sides of the well. Okay, this is the wall like that. And see, and when it is dug like this, so the earth has come out. The earth has come out, and this earth has been used to create an embankment around this particular well like this. So basically, the shape of the embankment is actually this, and well is located is very inside. So this is what is the structure that is to be created of an embankment. Okay, you can see these are two circles, one inside another. This is the what is the structure, and obviously this structure is the three-dimensional structure because this has got a little height also. This has been risen above the ground level. So this has got a little height also like this. Okay, this has got a little height also. Okay, like this. Now, so we are supposed to find out this particular height of the embankment. So clearly this complete structure of the embankment has been made by the earth removed from the well itself. So whatever is the volume of the earth removed, that will be actually the volume of the embankment in all. This is what is the strategy. So let us see what has been the volume of the earth removed. So volume of the earth removed will be the volume of the cylinder only, because the well is of a shape of a cylinder. So what is the volume of the earth removed? Let's see. Volume of earth removed is equal to 2 is equal to pi r square, is that is the volume of a cylinder. Okay, we have got all the values. 22 by 7. Radius of the well, and the inner diameter was 14, so the radius would have been 14 by 2, and it is a square, so square into height. Till what height or till what depth it has been dug? It has been dug to 15 meter. Okay, so this is what is the volume of the earth being removed. Okay, if we calculate, this comes out to be 2310 meter cube. Now this 2310 meter cube earth you have, and then you want to use this earth to create an embankment for whose that has to be evenly spread around that well, and the width is 7 meter. So clearly the volume of that embankment will be nothing but pi capital R square minus small r square into height. Okay, where this pi capital R square minus r square is the two-dimensional area. Okay, r is the radius of the outer wall of the embankment, small r is the radius of the inner wall of the embankment. Okay, and rather small r will be the radius of the well itself. Okay, so now let us just equate them. So it thinks like that. Okay, so 2310 is actually going to be 22 by 7 into capital R here is 14 square, because the width is 7 meter and radius of the well is also 7 meter. So the outer radius becomes 7 plus 7, 14. 14 square minus inner radius is just 7 square into height. Okay, if we calculate this further, we can calculate this to be 2310 is equal to 22 by 7 into 14 square is 196 minus 49 is into h. So in this way, we can go for h. So the h value can be come out as 2310 divided by 462, which is nothing but 5 meters. So this is what is the height of the embankment around the well such created. That is the answer. H value is 5 meter is the right answer. Now, the edges of a rectangular box are in ratio 1 is to 2 is to 3, and its surface area is 88 centimeters square. The volume of the box is. So clearly, we'll first try to create the sides, and then we'll try to create we'll make the surface area and we'll make it equal to the 88 centimeters square, from where we can get the value of the sides, and using those sides value, we can calculate the volume of the box. So let us do it step by step. First of all, let us assume let the sides of the rectangular box are x, 2x, and 3x. As they are given in the ratio, we can assume them to be x, 2x, and 3x like that. Now, he says the surface area is 88 centimeters square. What is the formula of the surface area? That surface area of the rectangular box, which is a shape of a cuboid always. Rectangular box is a shape of a cuboid. The surface area formula is twice of L into B plus B into H plus H into L. So let us just use this. Surface area of the cuboid is already given to be 88, has to be twice of L into B is X into 2X plus B into H is 2X into 3X plus H into L is 3X into X. This is how it goes. So if we solve this further, this comes out to twice of 2x square plus 6x square plus 3x square. If we solve this further, this comes out to be 6 plus 2, 8 plus 3, 11x square into 2, that is 22x square. Value is coming out to be 88. Clearly, x square comes out to be 4, which gives us the x value as 2. With x value of 2, we can find out each and every side that we had assumed initially, 2x, 2x, and 3x. So the sides of the dimension of the rectangular box is nothing but 2 centimeter, 4 centimeter, and 6 centimeter. These are the sides of the dimension of the cuboid is. Now he wants us to calculate the volume of the box. So volume of a cuboid will be used. Volume of a cuboid is nothing but L into B into H. So let us multiply all the three dimensions equal to 2 into 4 into 6. That is nothing but 48 centimeter cube. So that is the right volume that has been asked for of the box. 48 centimeter cube available in option number B. Now, a solid sphere of 6 centimeter diameter is melted and recast into 8 solid sphere of equal volume. The radius of each small sphere is. So we need to find out first the radius of the volume of each sphere. Okay, that can be found out by the volume of the complete solid sphere divided by 8. And from the volume of the solid sphere, the small solid sphere, we can find out the radius using the formula. So let us quickly do it. So the volume of the solid sphere, volume of the big solid sphere, rather volume of big solid sphere. Let us find out this. Volume of the big solid sphere is going to be, volume is always side cube. Volume is always calculated to side cube, but this is a sphere. So the volume of the sphere is given by 4 by 3 pi r cube. Okay, so we know the diameter of this particular sphere is 6, so radius will be 6 by 2, that is 3. So volume is going to be 4 by 3 into 22 by 7 into r value is 3, so 3 cube. This is how it is calculated to be, which gives us the value of 113.14 centimeter cube. This is the volume of the big sphere. He says this has been melted and recasted into 8 solid spheres. So obviously those 8 spheres have got the complete volume as equal to the one big solid sphere. That means each sphere, one such small sphere, one such small sphere will have a volume of the total volume of the solid sphere, that is 113.14 divided by 8, because that particular sphere has been broken down into 8 pieces. If we calculate this further, this comes out to be 4.14 centimeter cube. So this is the volume of a single sphere. Now he wants us to calculate the radius of this small sphere. So we can use the formula of volume. Volume formula is always 4 by 3 pi r cube, where this volume is already given to us as 4.14. So we can find out the r value here. So r cube is going to be 4.14 into 3 by 4 pi. If you put the value of pi as 22 by 7, then r cube value is coming out to be 3.375. And if you do the cube root of r, that is cube root of 3.375, you're going to get the r value as 1.5 meter. So that is going to be the right answer. Radius value is 1.5 meter, which is available in option number A, becomes the right answer. Now, in a quadrilateral ABCD with unequal sides, if the diagonal AC and BD intersect at right angles, then we have to find out which of them is true. So let us make the diagram first. Okay, so the diagram looks like this. Okay, this is what is the diagram of this question is. The diagram is looking like this. Okay, he said these things are right angles. The shape, the vertices are A, B, C, and D, and the center is O. Now we're supposed to find out in equality ABCD unequal side, the sides are not equal. AC and BD intersect at right angle. So AC and BD are the diagonals intersecting at the perpendicular thing 90 degree. Then we have to find out this. So let us do it one by one. We have to use Pythagoras. We have got four triangles. This is first right triangle, this is second right triangle, this is third right triangle, this is fourth right triangle. So if you see the first right triangle, the hypotenuse square is always base square plus perpendicular square. Hypotenuse of the first right triangle is AB square is equal to base is OB square plus perpendicular is AO square plus OA square. So this is how the first right triangle is defined in terms of Pythagoras theorem. If you see the second right triangle, the hypotenuse this time is BC square is equal to OB square plus OC square. If you see the third right triangle, the hypotenuse is now CD. So CD square is equal to OD square plus OC square. And the fourth right triangle, hypotenuse is AD. AD square is equal to OA square plus OD square. These are the four particular connections that can be made there. Now, we have to find the connection between AB, BC, CD, and DA. So clearly, if we add first and three together, so it comes out to be AB square plus CD square is equal to OB square plus O OB square plus OA square. The first right triangle has got OB square plus OA square plus OD square plus OC square. And similarly, if we add equation number 2 and 4 together, we're going to get to as BC square plus AD square is equal to OB square plus OC square plus OA square plus OD square. So if you see the right hand side of both of these relations, the right hand side of both of them are actually equal. Okay, so that means the left hand sides are also equal. That means we can say AB square plus BC plus CD square is equal to BC square plus AD square. So that is the right connection. So let's see where it is available. It is available in option number B. AB square plus CD square is equal to BC square plus AD square. So that is the right answer. Now, a circle tent is cylindrical to a height of 3 meter and conical above it. So first of all, let us draw this. So the tent has got beneath portion of the tent is of a cone. Okay, the lower portion of the tent is nothing but of a shape of a cylinder rather, and this is how the cylinder looks like. And above that, it is the shape of a cone. So this is how the complete shape of the tent is. That is, cone is surmounted by a cylinder. This is what is the situation. Now look at the dimension. Circus tent is cylindrical to a height of 3 meter. That means this very height is 3 meter. This height is given as 3 meter and conical above it, that we can see if the diameter of the base is 140 meters. So diameter of the base is always 140 meter, he says. So this is 140. So clearly the radius of this shape is going to be 70 meter. Here also and here also the radius is obviously diameter is half, so 70 meter. And the slant height of the conical portion is 80 meters. So slant height is this. He says this is 80 meters. So these are the dimension given to us. He wants us to calculate length of the canvas 2 meter wide required to make the tent. So the cloth that is required, the canvas that is required is actually related to the area of the tent. Okay, so we need to find out the area of that is the curved surface area of the complete tent. So we can find out that curved surface area of the complete tent by breaking that into two parts. Let us go with the first part. First part, let us consider that as a cone. So first of all, we are supposed to find out the curved surface area of a cone. So curved surface area of a cone, the formula of the curved surface area of the cone is nothing but is pi RL. This is the curved surface area of the cone. So we have got the pi value as 22 by 7. Radius of the cone as indicated here in the diagram, radius of the cone is 70. into slant height of the cone, that is also mentioned, that is 80. So this is what is the curved surface area of the cone. If we solve this further, this 7 can cut this 70 as 10. So it's going to be 22 into 800, which is nothing but fixed 5600, and let the pi be remained as it is, so that we can cancel few things. So 5600 pi meter square. Let's not cancel pi. So it's ultimately coming as 8 into 7 is 56. So 80 into 70 is 5600 pi meter square. Now let us find out the curved surface area of the cylinder. So curved surface area of the cylinder is given as the formula is simply uh, 2 pi RH. So let us put down the value. We have 2, we have pi as it is. Radius of the cylinder is similar to the radius of the cone itself, that is 70. And height of the cylinder is also given in the question as 3, so into 3. So if we put this value, we're going to get to reach as 70 into 2 is 140, into 3 is 420. So it becomes 420 meter square, 420 pi meter square. This is the curved surface area of the cylinder. Now we need to find out the total surface area. So total surface area will be simply the addition of curved surface area of cone and curved surface area of cylinder. If we add these two numbers, 5600 plus 420 and pi being common, so it actually comes out to be 6020 pi. So this is pi meter square. This is the total surface area. Okay, we can convert this 6020 into the actual value now. So it's 6020 into pi value is 22 by 7. If we put like this, so we are getting the value as 18,920 meters square. So this is the total surface area of the tent there with us. Now he wants us to find out the length of the canvas 2 meter wide required to make the tent. So we have a canvas in the shape of a rectangle where the width is 2 meter. He wants us to find the length so that the complete conical tent, the complete this particular shape tent can be made out of it. So clearly we can say the area of the canvas is actually equal to 80, should be 18,920 meters square. That is curved surface area of the tent. Curved surface area of the tent, that is the actual connection. Area of the canvas should be equal to area of the tent. Area of the tent we have calculated to be 18,920. So area canvas is the shape of a rectangle. So L into B is equal to 18,920, where the breadth of the canvas is already given to be 2. So L into 2 has to be 18,920, which gives us the L value as 18,920 divided by 2, which is nothing but 9,460 meters. So that is going to be the right answer. That is going to be the actual canvas length. So it is available in option number C. So it becomes the right answer there.